Now, let's take a moment to dive into implementing the getBookByID method in our book controller. This method is designed to respond to a GET request for a specific book, identified by its unique ID. We begin by using the @getMapping annotation to set up the route for this request, where /ID indicates that we expect a book ID to be passed through the URL. The @pathVariable annotation is what allows us to extract that ID from the URL and then use it as a method parameter. Within the method itself, we leverage the book repository to locate the book by its ID, which returns an optional of book. So if a book with that ID exists, we then wrap it in a response entity, returning it along with an HTTP status of 200 OK. Now, the beauty of Spring Boot is that this response is automatically converted to JSON format, which ensures that our client has a clear view of all the fields available in the response. In cases where the book isn't found, we throw a custom resource not found exception, which results in an appropriate 404 error. This approach keeps our API not only user-friendly, but also very informative, allowing clients to respond in a suitable manner when accessing resources.
In this method, we're going to use the @getting annotation along with a path variable, which will help us handle GET requests for a specific book identified by its ID. This way, we effectively map the incoming request to our method, making our API much more intuitive for users. So inside the method, we first try to retrieve the book using the book repository's findByID method. And hey, if the book just isn't there, we throw a custom exception called resource not found exception. This is super important because it allows us to manage errors properly and return a fitting 404 status code to the client. It gives clear feedback when a requested resource isn't available. Now, when we find the book, we wrap it in a response entity and send it back with an HTTP 200 OK status. The cool thing is, Spring Boot will automatically handle the conversion of the book object into JSON format for us. This ensures that our response is neatly structured and quite friendly for the clients to consume. So this approach not only simplifies how clients interact with our API, but also sticks to RESTful principles by providing meaningful HTTP responses based on the outcome of the request. It's all about creating a smooth and user-centric experience.
Next, we'll implement a simple data transfer object, or DTO, to really enhance our API's data model. This involves creating the book DTO class, which acts as a bridge between our book entity and the data we present to clients. In this class, we'll define 3 private fields: ID, title, and author. These are the essential attributes we want to share. Now, you'll notice we've intentionally left out the ISBN field. That's because it could be considered sensitive or just unnecessary for certain consumers. This selective exposure helps maximize both security and efficiency, leading to smaller payloads and, you guessed it, faster responses. The constructor for book DTO initializes these fields, making it super easy to create instances of our DTO with the required data. Plus, we provide getter methods for each attribute, which ensures that clients can access the data without modifying it themselves. This encapsulation is a core principle of object-oriented programming. It promotes a clear separation between the data structure and how it's presented. With this DTO established, we're in a great position to enhance our API responses and have better control over the data we share with our users.
So, first up, we start with the @getRequest annotation, which is a neat way to map HTTP GET requests to a specific URL pattern. This lets clients request a book based on its ID. Pretty cool, right? The method takes a long ID as a parameter, and we extract this from the URL using the @pathVariable annotation. Now, inside this method, we first try to retrieve the book entity from the book repository. If, by chance, the book with the specified ID doesn't exist, a resource not found exception is thrown. This gives us a clear error response for the client. Okay, once we find that book, we create a new book DTO instance. Now, this book DTO is like a simplified version of the book entity, only holding the essential bits like ID, title, and author. This approach not only keeps things tidy, but also enhances security by preventing sensitive data from being exposed. Finally, we return a response entity that contains our book DTO, ensuring that the client receives a well-structured JSON response that effectively communicates all the relevant book information in a concise manner.
The figure titled Distribution of HTTP Status Codes in RESTful APIs displays a pie chart with labeled slices for 200 OK, 201 created, 204 no content, 400 bad request, 404 not found, and 500 internal server error, along with a legend mapping each color to its corresponding status code. Now, if we take a closer look, the largest slice, 200 OK, occupies about 63 to 64% of the chart, which shows that the vast majority of responses are successful, full content responses. Next, we see the second largest piece, 201 created, at roughly 16%. This highlights that a significant portion of requests successfully leads to resource creation. It really underscores the importance of returning the proper location headers and adhering to 201 semantics for those create endpoints. Moving on, the 204 no content slice accounts for around 9 to 10%, indicating scenarios where actions complete successfully but with no body to return, which is particularly useful for deletions or update acknowledgements. Now, let's talk about the client errors, namely 400 and 404. These together make up another 9 to 10% of responses. This suggests that input validation and clear error messaging remain critical to minimize those failed client requests. Now, the 500 internal server error slice is the smallest, at about 1 to 2%. Indicating that while server-side failures are comparatively rare, they still exist and should definitely be monitored and logged. So overall, when we look at this chart, it emphasizes that successful responses are the norm, but there's also noteworthy activity in create operations and a measurable rate of client-side errors, which should inform our priorities for handling status codes, crafting meaningful error responses, and proactive monitoring. Let's dive into how we can implement the method for creating a new book in our API. The method we're working with is annotated with @post mapping, which means it handles HTTP post requests directed at the defined endpoint. In the createBook method, we're going to take a book object directly from the request body, which lets clients send new book information formatted in JSON. All right, so inside the method, we use our book repository to save that book to the database. This is super important because it returns the saved book instance. Why is that? Because we need to obtain any new properties that the repository has assigned, like the generated ID. Next, we create a book DTO object from that saved book, which includes only the fields we want to share with the client, like ID, title, and author. Now let's wrap it up. The method culminates in returning a response using responseentity.created, which sets the HTTP status to 201 created. This response not only includes the URI of the newly created resource, allowing clients to access it directly, but also wraps our book DTO in the response body. This way, we ensure that our clients receive a clear representation of the created book, keeping in line with the best practices for API design. First, we'll annotate our method with @getMapping, which is how we tell our application to handle GET requests at the /API/books endpoint. Inside this method, we'll use the book repository to grab all the book entries, and this will return us a list of book objects. Now, moving on, we need to transform that list of book entities into book DTO objects using Java streams. This step is crucial. DTOs help us tailor the data specifically for our clients, ensuring that only the relevant fields are visible. Each book gets mapped to a book DTO, capturing essential attributes like ID, title, and author. Finally, we construct our response using responseentity.ok, which indicates a successful response. In that same response, we'll add a custom header named xTotalCount, which gives clients a heads up on the total number of books returned. This is super handy for clients who may want to implement pagination, since it helps them gauge the total size of the dataset. The method then closes by sending back that list of book DTOs in the response body. Now, let's take a closer look at how we can implement versioning in our API. By adding the @request mapping/API/v1/books annotation to our controller, we're clearly setting the base endpoint for all requests related to book resources while specifying the API version. This practice is super important, as it allows our clients to stick to a specific version of the API, which is crucial for maintaining stability as we make changes or improvements down the road. For instance, if we decide to introduce new features or modify some existing ones, we can easily create a new controller for version 2, like /API/v2/books, and this way we won't disturb users who are still relying on version 1. This versioning strategy not only adds more flexibility to the API, but also promotes a smoother transition for our clients, making sure that their applications remain functional during updates. By using versioning, we really set a solid foundation for the growth of our API while being responsive to user needs, all the while safeguarding those existing client integrations. Now, let's take a look at how we can test our getBookById method to ensure its functionality. We start by setting up a test class that's annotated with @runwith springrunner.class and @webviewTest bookcontroller.class, which specifically loads the components we need to test the book controller. Next, we automatically wire in a mock MVC instance that allows us to simulate HTTP requests to our API endpoints. To keep our controller isolated from the underlying data layer during testing, we make use of the @mockbean annotation to create a mock instance of the book repository. This gives us the flexibility to define the behaviors for our data interactions without relying on a real database. Now, in our test method, getBookById returns book, we create a new book object with some predefined attributes. We utilize Mockito's when method to instruct our mock repository to return this book when we're asking for a specific ID. Finally, we simulate a GET request to our API endpoint and assert that the response status is 200 OK. With JSON path, we can also verify that the return JSON contains the expected title and author. This structure reassures us that our endpoint behaves correctly and returns the right data.
We've gone over how to define responses and refine the data model accessed via our API using DTOs. We highlighted the importance of having structured responses, handling HTTP status codes, adding metadata, and implementing version control effectively. We also delved into writing tests to ensure our API behaves as we expect it to. With these concepts in mind, you're now equipped to create a robust and user-friendly API that truly meets the needs of your clients. Thank you for following along, and keep coding.